Alright, here we go, folks. This section we're going to go over what we call definite integrals. So a few quick little notes here. So recall the integral of f of x dx is called an indefinite integral. Talked about that a few videos ago. A definite integral, on the other hand, has a form where you have your integral symbol, but you have what we call limits of integration. Okay, these will be actual x values. So as your x's go from a to b of f of x dx. Here, a and b are specific values of x. Okay, so a definite integral is used to calculate the area under the curve. Specifically, what I'm talking about is, let's say we have this, let's say we have some curve. Let's say right here is where x equals a. Let's say right here is where x equals b. Well, it turns out that the definite integral calculates all this area in between the curve and the horizontal axis there. All right. So with the definite integral, you're going to have specific values of x. So how do you evaluate this integral? Well, we're going to use something that's called the fundamental theorem of calculus. And it says what you do is you integrate, and you come up with your antiderivative. And then what you do is you then evaluate your antiderivative by plugging in what we call the upper bound. Okay? And then you subtract away what you get when you plug in the lower bound, when you plug that into your antiderivative. So what's the difference between this and what we've done in previous videos? Is that in previous videos, when we did the definite integral, you're calculating just the antiderivative. But for definite integrals, you're calculating the antiderivative, but you also want to find the area under that curve. So what you're doing is your answer is going to be a numerical answer. Whereas if it's a indefinite integral where there's no bounds, your answer is going to be a function. So that's the difference. Definite integrals, the answer will be a number. Indefinite, as we've done up to now, is going to be a function will be your answer. All right. So here we go. Some questions here. For example, suppose we want to evaluate from -1 to 1, t to the third minus t squared dt. Let me say this about the bounds. The bounds will always be written in the way where the lower bound will always be at the bottom. So the smaller number between the two bounds will always be at the bottom. Okay. So we want to integrate this. T to the third minus t squared dt. First thing we do is we integrate this like we've talked in previous sections. Well, this one, if you're just coming off of the substitution video, this one's not a substitution. This one is just, you're going to go integrate individually. In fact, we're going to do that for all of the integrals in this section. I'll make another video where you do integration by substitution and you plug in the bounds later. All right, so we know we get t to the fourth power divided by 4 minus t to the third power divided by 3. Okay, and then there's going to be a plus c. And so actually something cool is going to happen with those plus c's in just a minute. So what we have to do now is we have to take this entire function, and I like to use this notation. This means we're going to evaluate, plug in. We're going to plug in what happens as we go from -1 to 1. Okay? The fundamental theorem of calculus tells us that we always plug in the upper bound first. So always that top number there. And I'm sorry, that should be a positive one. All right, so that means we should plug in a positive 1 first. So let's do that. So it's going to be 1 to the fourth divided by 4 minus 1 to the third divided by 3 plus c. Okay. We're going to take that entire quantity, and it needs to now subtract. Where I get subtract from, that's the fundamental theorem. Subtract, and now we need to plug in the lower bound into our antiderivative. In this case, a -1. So it's going to be a -1 to the fourth over 4 minus a -1 to the third over 3 plus c. Okay. All right, so here we go. Let's just work this out. So 1 to the fourth is a 1. 1 over 4 is a 1/4. So we have 1/4 minus 1/3 plus c. Okay. Let's be careful here. A -1, let's do it like this. Let's take our time. Minus the quantity. A negative 1 to the fourth is a positive 1. So that's a positive 1/4. Okay, excuse me. Negative 1 to the third is a negative 1/3. But then since we're subtracting, it actually becomes a positive 1/3. So be careful with your symbols here. Plus c. Okay, so one more time. That was a negative 1 to the third power. That's a negative 1. So that's a negative 1/3. But since we're subtracting a negative 1/3, it's the same thing as adding. All right. We're going to distribute the negative and combine like terms. All right. So what happens? Let's see here. 1/4 minus 1/4. They're going to combine to 0. That's nice. A negative 1/3 minus 1/3. Be careful. That's not 0. That's a negative 2/3. And then the c's cancel. All right. So our answer is a negative 2/3. In fact, your c's will always cancel. Okay. So because of that reason, when you do your definite integral, you're going to end up with just a number, no plus c. So with that being said, I'm going to start to drop my c's whenever I have bounds because they're always going to cancel out. All right, first of a couple. Here we go. Next one. Integral of negative 2 to 2, x squared minus 4 dx. Okay, let's start off by, let's go ahead and integrate piece by piece. So we get x to the third over 3 minus a 4x. Okay. There is a plus c, but as we just discussed, it's going to cancel out, so I'm not going to worry about it. And then I'm going to evaluate this from x equals negative 2 to x equals 2. All right. Which value of x do we plug in first? We always plug in the upper bound, the top number. So that means we're going to plug in 2. So that's 2 cubed over 3 minus 4 times 2. Okay, this entire quantity is multiplied by the quantity. Put it in parentheses, very important. A negative 2 is cubed over 3 minus 4 times a negative 2. All right, the first set of parentheses, we get 2 cubed, so that's an 8/3 minus 8. Okay, minus the quantity of, be careful here, a negative 2 cubed is a negative 8, so that becomes a negative 8/3. Negative 4 times negative 2 is a plus 8. Let's see here. You can go to your calculator if you want to, but I'm going to be lazy here. I know that 8 is the same thing as 24 over 3. Why did I do that? Because I need, the same denominator. Minus 8/3 plus 24 over 3. Let's see here. We get 8 minus 24, which is a negative 16/3, minus a positive 16/3. Okay, so we have negative 16/3 minus 16/3, which gives us a negative 32/3. And we cannot simplify that any further. That's your answer. Negative 32/3. I highly recommend take your time, slow down, because it's very easy to mess up your negatives when doing these problems. All right, let's keep it moving. All right, then let's evaluate from 0 to 1 that function. We're not scared. Here we go. When we integrate, add 1 to the power, divide by new power. So it's x to the fourth over 4 minus 6x to the third over 3 plus 4x squared over 2. There is a plus c. We're going to drop it. And we're going to evaluate this from x equals 0 to x equals 1. Not necessary, but I recommend it. If you can simplify your function at all, go ahead and do that. And we could do that here. So this is x to the fourth over 4 minus 6x cubed divided by 3 is a 2x cubed. And 4x squared divided by 2 is a plus 2x squared. So like I said, not necessary, but I recommend it. Go ahead and do it. All right, what do we plug in first for x? Uno. 1 to the fourth over 4 minus 2 to the 1 cubed plus 2 times 1 squared. That's minus the quantity. Can't stress it enough. Put it in parentheses. 0 to the fourth over 4 minus 2 times 0 cubed plus 2 times 0 squared. Okay. We got 1/4 minus 1 cubed is 1 times a negative 2, so minus 2. Plus 2 times 1 squared. 1 squared is 1 times 2 is 2. Okay, that whole thing needs to be subtracted by, well, let's see, 0 to the 4th over 0. 0 to the 4th is 0. 0 divided by 4 is 0. 0 cubed is 0 times 2 is 0. 2 times 0 squared. 0 squared is 0 times 2 is 0. That whole thing, thank you, becomes 0. That's nice. And then our first set of parentheses, negative 2 plus 2, that sums to 0, and we're left with just a positive 1/4. That is our answer. Okay, let's see, just a few more here. Rational powers. All right, so the first thing we're going to do with this one is we need to rewrite that cube root of x. Cube root of x is x to the 1/3 power. And then what do? We're going to bring that x to the 1/3, we're going to bring it up top. So notice I still have my integration symbol because we are not integrating, we are rewriting. But now we're in business and we can integrate. Let's do that. When you add 1 to a negative 1/3 power, it becomes x to the positive 2/3 power. Negative 1/3 plus 3 over 3, 2/3 power. Okay. X to the 2/3, remember we have to divide by that same power, 2/3. Okay, plus c, I'm not going to worry about it right now. And this is going to be evaluated from x equals 1 to x equals 8. I like to rewrite my dividing by 2/3. We talked about this a few times now in previous videos, but that's going to be 3/2 times x to the 2/3. X equals 1 to 8. And now we plug in 8. So we have 3/2 times 8 to the 2/3 power minus the quantity of 3/2 of 1 raised to the 2/3 power. Okay. All right, 8 to the 2/3 power. That sounds scary, right? So feel free to use your calculator. I can't see you. But 8 to the 2/3 power, we can actually do that without using a calculator, believe it or not. So 8 to the 2/3 power, what does that mean? That means that we need to take the cube root of 8 squared. Okay, right? So that means the cube root of 64, and well, 4 is the cube root of 64. All right, and so that's what happens. So if you take, or another way of looking at it is you take the cube root of 8, which is 2, and then you square it, you get 4. So either way, you're going to get 4. All right, so 8 to the 2/3 power is 4. So this becomes 3/2 times 4 minus 3/2 times 1 to the 2/3 power is just 1. Okay, put that in parentheses if you want to. All right, 3/2 times 4, we know we can cross cancel. Divide the 2 by 2, which is 1. Divide 4 by 2, which is 2. So 3/2 times 4 is 6. So we have 6 minus 3/2. And now I need to rewrite 6 as something over 2. Well, that something is 12 over 2 minus 3 over 2. Final answer, 12 minus trace is 9 over 2. 9/2 is that definite integral. All right, hope you guys are a lot more comfortable with this integration stuff. All right, here we go. Just a couple more. What are we doing here? Integrating from 4 to 9, negative 6t to the negative 1/2 power minus 8. All right, let's go ahead and integrate. We're in the correct form. So when we integrate a negative 6t to the negative 1/2, we get a negative 6t to the positive 1/2. When we add 1 to the negative 1/2, we get a positive 1/2. Divided by that same 1/2 power, minus 8t. And this entire thing needs to be evaluated from t equals 4 to t equals 9. Okay. All right, before we do that, let's clean this up. When I divide a negative 6t to the 1/2 by a 1/2, it's the same thing as multiplying it by the reciprocal, which in this case will be 2. Okay, that 2 only multiplies the negative 6t to the 1/2. T equals 4 to 9. And then lastly, what's 2 times a negative 6? It's a negative 12t to the 1/2 minus 8t. All right, we are in business now, folks. Now we just plug in t equals 9. Okay, so negative 12 times 9 to the 1/2 power, which means take the square root. We'll do that in a second. Minus 8 times 9, minus the quantity. Now we plug in 4. Negative 12 times 4 to the 1/2, minus 8 times 4. Okay. 1/2 power is the square root, so the square root of 9 is 3. 3 times a negative 12 is a negative 36, minus 72, minus 4 to the 1/2 is 2. 2 times a negative 12 is a negative 24, minus 32. All right. Now it's just a matter of cleaning up everything. So let's see here. Negative 36 minus 72, that's a negative 108. Minus a negative 24 minus 32, that's a negative 56. If my math is correct, my arithmetic. So this is a negative 108 plus 56, right? I hate arithmetic. And then that should equal a negative 52. So there is our definite integral. Listen, I'm 100% confident that my calculus was correct. Y'all double check my arithmetic. All right. Here we go. All right, I think this is the last one. I'll make this the last one. All right. So we need to integrate from 1 to 16, negative 3x minus 3 over the square root of x. So this is going to involve pretty substantial rewriting. Okay, so the first thing I want to do is I want to rewrite the square root of x as x to the 1/2 power. Okay. All right. And then what I can do next, still not ready to integrate, is because I have a single factor, well, not because I have a single factor, but what I could do is I could break this fraction up. Remember the rule of fractions, a plus b over c. Remember we can rewrite that as a over c plus b over c. Well, that's what we're going to do here. So this is a negative 3x over x to the 1/2 minus 3 over x to the 1/2 power. Okay. Now we're going to simplify those fractions. So how do we simplify? Remember, whenever we divide, we subtract the exponents. So for the first term, we have a negative 3x over x to the 1/2. Well, the understood power on the numerator, x, is a 1. And downstairs is a half. So 1 minus a half leaves us with a positive 1/2. So the first term simplifies to a negative 3x to the positive 1/2. I subtracted the powers there, right? If I have, so here's the rule. If I have x over a divided by x to the b, remember it's x to the a minus b power. Okay? Minus, well, technically, if you want to think of it like this, the numerator for the second term, it has an x to the 0 if you want to think of it like that. Because x to the 0 is 1, 1 times 3 is just 3. Well, then 0 minus a half is a negative 1/2. In fact, that's the reason why whenever we bring up something to the opposite location, we take the opposite of the power. It's for that reason. So the second term becomes 3x to the negative 1/2 power. I just swung that x to the negative 1/2 up top. Okay. Now we are ready to integrate. Here we go. We get a negative 3x, add 1 to 1/2, you get 3/2, divided by that same 3/2 power, minus 3x, add 1 to a negative 1/2, you get a positive 1/2, divided by 1/2. There's a plus c, but it's going to go away. And we need to evaluate this from, not t, but x equals 1 to x equals 16. All right. So let's see here. I definitely want to clean this up. So dividing by 3/2 means we're going to bring up a 2/3. So this is 2/3 times a negative 3x to the 3/2 minus the reciprocal of a 1/2 is 2. So it's going to be 2 times 3x to the 1/2. And we still got to evaluate it from x equals 1 to x equals 16. Okay, at this point I want to go ahead and multiply and simplify this a little bit. So 2/3 times a -3, the 3's are going to cancel, but I still got that negative, so it's going to be a negative, right, these become 1's. So I have a -2 x to the 3/2 minus 6x to the 1/2. So I know it's a bit of work to simplify these, but hopefully you see the appreciation. This becomes much simpler to evaluate, to plug in values into. And that's exactly what we're going to do. What are we going to plug in first for x? We're going to plug in 16. -2 times 16 to the 3/2 minus 6 times 16 to the 1/2. Okay, that entire quantity needs to be subtracted away from the quantity of, now we plug in 1. All right. Okay, here we go. Once again, you can go to your calculator if you want to, but 16 to the 3/2. That denominator of 2 indicates we need to take the square root of 16. So the square root of 16 is 4. 4 to the 3rd power becomes 64. So it becomes a -2 times 64. In fact, let's do it like this. In fact, let me show you my calculator really quickly, just so you guys don't think I'm giving you the wrong information. So is it 16 to the 3/2? All right, so let's make this a little bigger. All right, so if I do 16, and if I raise it to the 3 divided by 2, okay, if you have a calculator that doesn't bump you up as a superscript and what you see is the actual caret, make sure you put 3/2 in parentheses. But there, it's the 64. You take the square root of 16, which is 4, and then you raise it to the 3rd power, which gives you 64. Okay? All right. So -2 times 64 minus, closed up too soon, minus 16 to the 1/2 means we take the square root of 16. Square root of 16 is 4 times 6. So let's do it. So 6 times 4. We'll clean that up in a second. Minus, let's see, 1 to the 3/2 is 1. 1 times a -2 is a -2. 1 to the 1/2 is 1. 1 times a -6 is a -6. So we have, let me do a different color. -2 times 64 is a -128 minus 24. Whatever that is, it needs to be subtracted away from -2 minus 6, which is a -8. Let's see, -128 minus 24 is a -152. Minus a -8 is +8, so the final answer is a -144. Once again, double check my arithmetic. I'm confident in the calculus. Alrighty, folks. Once again, sorry for the longer video here, but that's how you do integration, or excuse me, that's how you do integration with bounds. We call that a definite integral. Alright, see you guys in the next video.